Before configuring VPN NAT to allow L3 VPN users to communicate, let's look at VPN NAT technology. VPN NAT implements NAT within VPN instances. VPN NAT emerges with the introduction of MPLS VPN. NAT converts addresses to alleviate the IPv4 address shortage. NAT takes effect in either inbound or outbound direction. In an MPLS VPN usage scenario, an internal server in a VPN instance is deployed, and users in different VPN instances need to communicate using NAT. Next, let's look at the networking requirements for L3 VPN users to communicate with each other through VPN NAT. In an L3 VPN scenario, CE1 and CE2 belong to the private network VPN NA. The private network prefix of CE1 is 10.1.0.0, and the mask length is 16. CE1 and CE2 can communicate with each other only after VPN NAT is configured on PE1. BGP MPLS/IP VPN services are configured on each device. VPN NAT is configured on PE1. Private VPN users on CE1 and CE2 can communicate with each other. CE2 can access the internal NAT server deployed on CE1. Before configuring the NAT device, let's look at the configuration roadmap. Step 1. Configure BGP MPLS/IP VPN to ensure that VPN instances are running properly. Step 2. Create a VSM HA backup group and a VSM HA service instant group. Step 3. Create a NAT instance and bind it to the VSM HA service instance group. Step 4. Configure a mapping between the private IP address and port number pair and the public IP address and port number pair for an internal server in a specific VPN instance. Step 5. Configure a NAT traffic diversion policy. Step 6. Configure a NAT address pool and a NAT conversion policy. Now, let's look at how to configure the device. Step 1. Configure BGP MPLS/IP VPN on each device. Details about this step are not provided here. The focus is on how to deploy the VPN NAT service on PE1. Step 2. Create a VSM HA backup group and a VSM HA service instance group. We can see that the VSM HA backup group has been configured using the service location command, and the VSM HA backup group has been bound to the VSM HA service instance group. Step 3. Create a NAT instance named NAT1 and bind it to the VMHA service group. Step 4. Configure an internal FTP server in a specific VPN instance. Assign the FTP server a private IP address, 10.1.1.226, a public IP address, 11.1.1.2, and a VPN instance named VPN NA. Step 5. Configure a NAT traffic diversion policy. According to the preceding deployment requirements, CE1's private network prefix is 10.1.0.0, and mask length is 16. CE1 can communicate with CE2 only when VPN NAT is performed for CE1's traffic on PE1. Configure ACL 3001. It contains two traffic classification rules. Rule 1 is used in a NAT traffic diversion policy. Rule 1 matches traffic with a network segment address of 10.1.0.0 and mask length of 16. The matching traffic is forwarded to a service board for NAT processing. Rule 2 is used in a NAT address pool-based conversion policy. Traffic matching Rule 2 is processed by NAT using a NAT address pool. Then configure an ACL-based traffic classification policy. Configure a traffic behavior and bind it to the NAT instance named NAT1. Define a traffic classification policy to associate with the ACL classifier and behavior. Apply the traffic classification policy to the inbound interface connecting PE1 to CE1. Step 6. Configure a NAT address pool on PE1. Configure a NAT conversion policy to translate IP addresses of traffic sent by CE1 to public IP addresses in the configured address pool.